Okay. Don't forget that when you put data in your calculator, it's also going to give you a 5-number summary. So, let's see if I have a data list in from the other day. It doesn't really matter. If I hit stat and calc and do the one variable stats like we've been doing, if you arrow down to the second page, starting on the second page, you can see my min and my Q1 and my median and my Q3 and my max. So it's going to give you the 5-number summary when you put data in your calculator also. But because this one was already in order, it's easy enough to find it by hand. If it's a small data set like this. If it's a large data set, I don't want to be trying to find stuff by hand, so I'm going to put it in my calculator.
How did you just know that it was like 49 and 60?
Oh, because remember, if this is the middle, then I'm looking at the middle of my other data set, and it had 5 numbers, so it's going to be the third. Do you understand what I'm saying? It's like you have once you've halved it, then you half the halves. So it was then this half, and so that was the middle of that half, and that half, and that's the middle of that half. Does that make sense? Okay. So now we're going to draw a box plot. So we're going to use the data that we just found our max, min, and Q1, Q3, etc. for. So I'm going to write them down right here. Q1 is my min. I should do min. Min is 2. Q1 was 49. Median was 51. My Q3 was 60. And my max is 63. All right, so we need to determine our upper and lower fences. So we have to find our IQR. My IQR, remember, is Q3 minus Q1. So in this case, that's 60 minus 49, which is 11. And now to find my upper and lower fence, I'm going to take that number and multiply it by 1.5 and subtract it from Q1 and add it to Q3. So Q1 minus 1.5 times my IQR. So in this case, that is 49 minus 1.5 times 11. $32.5. This is my lower fence. And then to find my upper fence, I'm doing the same thing, but this time I'm adding to Q3. It's always 1.5, and you're always subtracting from Q1 and adding to Q3. That part never changes. So 60 plus 1.5 times 11. All right, so remember, those values are what we're using to determine whether or not we have any outliers, which we do, but we will deal with them in just a minute. So step 2 says draw a number line long enough to include the maximum and minimum values. They drew the number line for us down here at the bottom. That was nice. Insert vertical lines at Q1, M, and Q3. So my Q1 is 49. My median is 51. And my Q3 is 60. And we're going to make a box. From those. Label the upper and lower fence. So my lower fence is 32.5. I'm just going to label it down here on the number line for right this second. Lower fence. Where's my upper fence? 76. Oh, I can't even fit it on here. It didn't go far enough to. to label my upper fence. Draw a line from Q1 to the smallest data value that is larger than the lower fence. So my smallest data value is 2. But that's way outside the fence, so we're not going to go that far down. We're just going to go the next lowest number, which is 43. So that's my whisker. And then my largest data value that's inside the fence is 63. Those are whiskers. Anything that's below your lower fence or above your upper fence is an outlier, and you can leave it off. Now notice what we don't do. We leave off the outliers, but we don't change our median. I mean, if you think about it, if you just drop, so don't change your outliers before you find your median and all of that stuff. Even if you can look at it and know it's an outlier, don't eliminate it. You're still going to count your median just like it is. Does everybody understand what I'm saying? Because technically it would have made this, dropping off the outlier makes it a data set of 10 and not 11, which would mean I wouldn't have an exact value and I'd have to find an average one. We don't do that. We don't adjust like that. You don't throw them out until after you started to craft your box and whisker. Okay. Using a box and quartiles to describe the shape of a distribution. So this is just for your benefit to see what a box and whisker. This is why when I asked you that question in My Labs Plus, I was like, I feel like that should come after the next time's notes, because when you see the box and whisker plots, just like with a normal bell curve, the tail wags the dog. So if you have a longer whisker on one side, then that's the way it's skewed. If I have a long right whisker, it's skewed right, just like that. And if it's a long left whisker, it's skewed left. So it's pretty easy to tell if you actually have the box plot. Okay. All right, the data to the right represents the number of chocolate chip cookies, chocolate chips per cookie in a random sample of a name brand and a store brand. Complete parts A to C below.
Who really said, I'm going to count every single one of these stuff?
I don't know. But you know what? So there's like a data website that I pulled data from actual studies, like to do that. And they did that. It was a school. They counted the chips in the Chips Ahoy cookies.
Imagine getting 35 chocolate chips on your cookie.
Yeah, right?
That's a lot.
Bruh.
That's a lot of chocolate chips. I think that might be a little overkill. But, I mean, it happens, I guess. And then what if you're this guy and you only got 17, or 16? Like, for real? And I get 35? That's not fair. Okay, draw side-by-side box plots for each brand of cookie. Label the box plots N for the name brand and S for the store brand. So, probably the easiest thing for us to do, are they in order? No, of course they're not. Oh, jerks. So I guess we're going to have to put it, I think it's probably easiest to put it in our calculator, because it'll put it in order for us. I mean, you can put it in order yourself if you want to. I think I'll just put them in my calculator.
That's what I do.
And your calculator will do box plots also. In the same place where we do bell curves, there's a deal for box plots, so we could do that if we wanted to. But this one's probably going to be just as easy to answer just by finding the median and the max and min.
And then in L2, do we put the store brand?
That's what I'm going to do.
Okay.
There's multiple ways you could do this, but
It's not going to.
it won't give me a median if I do that. It does give me min and max though. So I just thought I'd try. If you do second stat and arrow over to calc, or stat calc, and do two variable stats, it'll do stats for list 1 and list 2, but it doesn't give the median. But it does give the max and min, like if you scroll down. it has the min for the first set and the max for the first set. So if that helps me, my second set was store brand. So my min is, does that help me? It eliminates this one. Let's see, and it eliminates this one. So it's this. Because my minimum for my name brand is 22. And then my minimum for my store brand is 16. So, does there appear to be a difference in the number of chips per cookie? Well, yes. There does.
The name brand has more, right?
Yes. Does one brand have more consistent number of chips per cookie?
Probably the name brand, but the store brand looks kind of spread out.
Very good. I would say yes, the name brand has a more consistent number of cookies because the store brand, the scatter plot is, my whiskers are longer, it's all spread out. So I would say the name brand.
Ooh.
There you go. Box and Whisker Plots. Pretty easy. So that's the last section in this little unit. So I haven't opened the assignment, but I'll open it in just a second. So we will have a work day tomorrow and then take the mastery assessment on Friday. Are y'all good with that? Is that good? Okay.
Is this test on Monday going to be difficult?
We'll probably not take it till Tuesday. Because I'm going to give you guys tomorrow and Friday, I'll give you a paper review, and I'll open the online reviews and stuff too, and then we'll take it on Tuesday. But no, it's not going to be difficult.
All right. Woo.
I mean, I think this stuff's pretty simple.